have our second example. So this time we need to find the area to the right of z equals to negative 1.35. So again, first step, we need to draw or sketch the normal curve. So here it is, and the location of the z, which is negative 1.35, is here, which is to the left of the mean, which is 0. So next step, we need to shade the region of the curve according to the condition of the z value. So this time, we have the clue word here of the condition, which is to the right. So to the right, meaning that your the shaded region is to the right of the z negative 1.35. So this is our shaded region we're in. We need to find the area. So we need to find that area. For the third step, again, use the table of area under the normal curve to find the corresponding area. So we have, again, z is equals to negative 1.35. From this negative z table, we have negative 1.3 and again 0.05. So the intersection is equals to 0.0885. So we have the same z value from our previous example, which is example number 1. So they have the same z corresponding area from the table of from the z table rather. Now we have the fourth step, wherein we need to choose the appropriate operation based on the step 2 and 3. So we have here the second operation or second condition. When the z value is to the right or any terms like above or greater than, we need to subtract 1 by the obtained value. So we obtained the we have a value of 0.0885 from the third step or from the table of areas. So since the shaded region is to the right, we will subtract 0.0885 from 1. So their difference, 1 minus 0.0885 is equals to 0.9115. Therefore, for the last step, we need to label the shaded region and draw the conclusion. So here is our normal curve with the shaded region, which is to the right of z is equals to negative 1.35. So this region and this area, the area of this region is equals to 0.9115. The area to the right of z is equals to 0.9115. Now we have our last example, which is to find the area between z is equals to negative 1.3 and z is equals to 2. So this time we have to find the area between the two z values. So here is the keyword. So let's have for step 1, draw, sketch a normal curve and locate the given z value. So here is the normal curve again. We have z is equals to negative 1.3 and z is equals to 2. Here it is. So we are looking for the area in between these two. So this region. And we need to shade the region of the curve according to the condition. So in between z of negative 1.3 and z is equals to 2. So we have here z negative 1.3 and z is equals to 2. So here is the shaded region. which is in between the two z values. For the third step, we need to use the z-table to get the area that corresponds to the z values. So we need to first find the area for z is equals to negative 1.3. So let's have the negative z-table. We have negative 1.3, and since it's just 0.30, so we have 0 here. And then their intersection is equals to 0.0968. For the area of the z is equals to 2, we need to use the positive z-table. So we have here the positive 2, and since we don't have decimal place, we just have 0. And the shaded the intersection, we have the value of 0.9772. And for the fourth step, we need to choose the appropriate operation based on the step 2 and 3. So here is the condition. When the shaded is in between, we need to subtract the biggest by the smallest area or value that we have from step 3. So since the shaded region is between the two z value, which is negative 1.3 and positive 2, and their areas respectively are 0.9772 and 0.0968. We just need to subtract 0.9772 by 0.0968, and the difference we have equals to 0.8804. Therefore, for our last step, we need to label the region and draw the conclusion. So here is the region for the area between z is equals to negative 1.3 and 2. So this region has an area which is 0.8804. Again, therefore, the area between z is equals to negative 1.3 and z is equals to 2 is 0.8804. So that's it for our lesson number 6.